In this video, we're going to learn about the concept of a slope and how to go about calculating it. Well, in most standard textbooks, you would find the slope defined in a way such as the one shown on the screen above. Well, this way of understanding the concept of slope is not only boring, but it also does not give the intuition behind the concept. In other words, just by reading the definition of a slope, that is, the slope of a relationship is the change in the value of the variable blah blah blah, is simply not going to help you understand what exactly do we mean by a slope. So the purpose of this video is to help you do just that. So I assure you that by the end of this video, you're going to be absolutely confident about the different types of slopes, and hopefully these concepts are going to stay with you for the rest of your life. Okay, so let's begin. First of all, I need you to remember this very clearly. Understanding slope means understanding two things. Number one, steepness, and number two, direction. So these are the two concepts that we're going to be looking at in this video. I repeat, number one, steepness, and number two is direction. But before I explain what exactly do we mean by steepness and direction, let's try to understand the concept by looking at a very simple everyday example. So just imagine for a moment that you're cycling along a straight road as shown in the center image on the screen. So as you can see, when you're cycling along a straight road, you don't have to exert any effort because you're neither going up the hill nor are you going down the hill. And students often find it very difficult to understand why the slope of a horizontal straight line is always zero. But if you just remember this image, then you're going to have absolutely no difficulty in remembering this basic fact. And of course, as you can see in the images on the left and the right, the first person is simply riding down the hill. So whenever you see a line that is downward sloping, just imagine yourself riding down the hill. And obviously, a downward sloping line is always going to have a negative slope. On the other hand, whenever you see a line that has a positive slope, such as the one in the third image, now the trick here is to imagine yourself going up the hill, and obviously when you're riding up the hill, it's an upward movement, which is obviously always going to be a positive movement. And just in case you're still having difficulty remembering the positive sign, just imagine your feelings while you're riding up the hill. Aren't you happy and excited? Because you're soon going to be able to enjoy the lovely and beautiful view from the top. Okay, so by the way, we've already understood the concept of direction of slope because an upward movement is associated with a positive slope, whereas a downward movement indicates a negative slope. So the first take-home message from this point is that just by looking at a slope, you can tell the nature of the relationship, that is, whether it's negative or positive. Now this point about the nature of the relationship between the x and y variables is going to become clearer later on. But for now, you just need to remember that the slope always gives an indication of the direction of the movement. Next, we're going to understand the concept of steepness. Now look carefully at the images on the screen and pause the video and think for a moment whether you can see any difference between image A and image C. Okay, so I'm going to presume that you did pause the video, and hopefully you noticed that in both the images, that is A and C, the person is cycling up the hill, so it's an upward movement, that is, the slope is obviously positive. So as far as the direction of the movement is concerned, there is no difference between image A and image C. However, if you have looked carefully at the images, you should be able to conclude that there is a difference between the steepness of the two slopes. So if I were to ask you which of these images indicates a steeper slope, is your answer going to be A or C? Once again, I would encourage you to actually pause the video and think for a moment whether you think A is steeper than C or vice versa. Well, even if you were not able to guess the answer is now going to be obvious. So the person in image C was riding up a steeper slope than the person in image A. Okay, now I need you to understand this, okay? I really need you to understand this. So just by looking at an image, you can tell if one of the slopes is steeper than the other. So in short, without doing any calculations whatsoever, you can tell easily just by looking at an image, such as the one shown on the screen, whether one slope is steeper than the other. And just in case you're wondering how you can do so, then simply remember the trick that the higher the slope, the steeper the line is going to be. So if I were to ask you what do we mean by a slope, you simply need to remember that a slope represents steepness. And now if you remember, this is why I had said that the slope of a horizontal line is always going to be 0, because obviously it is not steep at all. The concept of steepness is only relevant when you're actually making a movement either in an upward or a downward direction as shown in the images on the screen. So a very simple shortcut to remember this is simply to ask yourself, how fast are you going up or how fast are you going down? And now in this graph you can see two lines, and if I were to ask you which of these lines is steeper, and hopefully you can tell me just by looking at the graph that line 1 is steeper than 2. And up till now we have not yet explored the concept of slope formally. But if I were to ask you how you would represent steepness, that is the slope, numerically, then you should remember that steepness or slope is formally defined as a ratio of run over rise. So the run simply indicates the change in the horizontal direction, while the rise indicates the change in the vertical direction. And of course, the important point to notice is that even though the run and rise values may be different depending on which 2 points we take on that same line, but the ratio of the run and rise, that is the slope, is the same. Now this brings me to the next extremely crucial point that I need you to understand. Okay, so normally whenever I ask my students if they can tell me what is the slope of a straight line, most of them would just say that it's 0. And my point is that first of all, students need to distinguish between the different types of straight lines. As you can see, a straight line may be like the horizontal lines shown in the first image, or it can be a vertical line, and of course it can also be a slanting line like the third one. So it's incorrect to state that the slope of a straight line is simply 0 because as you can see on the screen, there are different types of straight lines. And so the slope is going to be different for each type of straight line. And as you can see again on the screen that the first, second, third and fourth lines are all straight, because a straight line is obviously simply just a line that is not curved. So we can see that all of these lines are straight, yet they have different slopes. Therefore, always remember that there are 4 different types of straight lines. One is a rising line which has a positive slope, another is a falling line which has a negative slope, and of course we have either a horizontal line or a vertical line, but a horizontal line has a slope of 0, whereas a vertical line is said to have an undefined or an indefinite slope. Now, as far as a horizontal line is concerned, I've already given you the intuition behind why this is so. So once again, just remember that you need to imagine yourself cycling, and when you're cycling on a straight road, that is, you're not going up the hill or you're not going down the hill, then as far as the concept of slope is concerned, which is obviously relating to the inclination or the steepness of a line, then there is no steepness involved when you're going straight. So in short, whenever you look at a horizontal line, you should remember that a horizontal line simply does not have any steepness, and therefore the slope is always going to be 0. Now you must be wondering why the vertical line has an undefined slope, but I'm going to explain that later on. For now, I want you to focus on the first two images where it shows two slanting lines, but the slope of the second line is steeper than that of the first one. And first of all, please note the fact that we are no longer comparing two lines, one of which is positively sloped and the other is negatively sloped. No, we're simply looking at two lines, both of which are negatively sloped because both of them are downward sloping lines. So obviously the slope is negative for both. But if I were to ask you which one has a steeper slope, then hopefully you should be able to see that the second one is steeper, and the idea is as follows. If you compare the two slopes, the steeper slope indicates faster movement. So always remember that when you're comparing two lines, then the line that has a steeper slope is always going to have the numerically bigger slope. So look at the four examples on the lower half of the screen, and here you can see that all four lines are positively sloped. Why? Because all four lines are upward sloping. However, if you compare the four lines, not all of them have the same slope. In other words, the direction of the movement is the same for all four, but the steepness, that is the slope, is different for each of these four images. So the first line has a slope of just 0.1, whereas the second line is a little steeper than the first line, so it has a slope of 1. And then the third line is even steeper than the second one, and this time it has a slope of 2. And finally, the fourth line, which is very steep, in fact it's the steepest out of the four lines, has a slope of 4. So in short, whenever you look at two lines and you need to compare their slopes, then you simply need to remember this rule, that is, the steeper the line, the higher the slope. And of course, another way to say the same thing is that the steeper the line, the bigger the slope is going to be. So here, if you compare L1 and L2, L1 has the bigger slope. And once again, I would like to point out that you do not necessarily need the x and the y coordinates in order to comment on which of these slopes is larger. So even without the coordinates, you can tell just by looking at the image that the first line has the steepest slope, and of course the third line has a slope of 0 because it's a horizontal straight line. Okay, so now I want you to quickly test yourself. If I give you three labels, steep, steeper, and steepest, can you label which one of these is steep, which one is steeper, and which one is steepest? You can pause the video and see if you can do that. Okay, so I believe I've already said enough about how you can compare two slopes and comment on which one is steeper. And the key point to remember is that it's incorrect to say that a straight line always has a slope of 0, because you first need to ask whether that straight line is a vertical straight line or a horizontal straight line, because if it's vertical, then obviously we've already seen that a vertical straight line has an undefined or an indefinite slope, whereas a horizontal straight line has a slope of 0. So when it comes to straight lines, you need to be very careful about what kind of straight line it is. So the concept of steepness of a slope is only relevant when we are talking about a slanting line. Either it's going to be a downward sloping line or an upward sloping line. And of course, we know that a downward sloping line always has a negative slope, whereas an upward sloping line always has a positive slope. However, as we have seen, it's not enough to be able to state whether the line has a positive slope or a negative slope, because sometimes you may be given two or more lines, all of which have a positive slope as shown on the screen right now. And even though, as you can see, no numerical value is given for the slopes, but it's very easy to tell at a glance that some of these lines are steeper than the others. But of course, if you are given the coordinates, then you can always calculate the slope, and as you can see, the image now indicates the value of the slope. And notice that the flat line simply has a slope of 0, whereas the vertical line has an undefined or an infinite slope. Okay, so I think we've now spent enough time looking at various slopes, but visualizing the slopes is not enough. So here on the screen you can see the formal definition of a slope, and if you remember, this is what I had started this video with. But I preferred to convey the concept graphically and visually before we delve into the formal definition. So a slope is simply defined as the rise over the run, and it can be calculated using the formula stated on the screen. In short, as you can see in the worked examples towards the end of this video, you simply need to select 2 points on the line, and then you need to note down the x and the y coordinates for each of those 2 points. And once you have done so, then you can calculate delta y and delta x in order to compute the slope. In this particular graph, you can see that the line has a positive slope and that the value of this slope is 3/4. Next, here you can see that the line has a negative slope, and this time the slope is -3/4. Please take note that the minus sign is extremely important when you are indicating a negative slope. Okay, so this brings me to the end of this video, and here on the screen you can see a summary of some of the important points that you need to remember regarding slopes.